number 1I from homework, graphing rational expressions 2. And we have a cubic function in the numerator and a quadratic function in the denominator. So the first thing we're going to do is we're going to factor. So when we factor this expression, we're going to end up with 3x minus 2, x minus 2, x plus 1 in the numerator, and in the denominator we end up with x minus 3, x plus 1. So we can see that we have common factors. They're going to cancel out, and this is going to result in a whole. So I'm just going to make note of that. The whole at x equals -1. We have zeros that are going to come from the numerator. The zeros are going to be from these numerators at x equals +2/3 and x equals +2. And then we have our vertical asymptote. Our vertical asymptote, color will I choose here? Our vertical asymptote is going to be at x equals 3. So I'm just going to draw my vertical asymptote to start. There's my vertical asymptote. Okay, we have our zeros. Just drawing our zeros at x equals 2 and x equals 2/3, maybe somewhere around here. And we have a whole at x equals -1. We'll draw that in when we draw the function. We can determine a y-intercept. Y-intercept is an easy coordinate to find because we just plug in 0 into the expression. We plug in 0, we end up with +4 in the numerator, -3 in the denominator, so our y-intercept is going to be at y equals -4/3. We know that's going to cross somewhere right around here. So last thing we want is our slant asymptote. We're going to get our slant asymptote by long division. So I'm going to divide the function. So I'm going to divide x minus 3 into the numerator, and I'm going to write it as 3x squared minus 8x plus 4. We don't need to divide the canceled factors because we know that already divides evenly. So we end up with 3x okay, so when we end up with our x plus 4, so we're going to end up with 3x plus 1, and we get a remainder of +7. So 3x plus 1, we're just going to sketch in maybe something like this. Okay, our points are consistent with our slant asymptote. We can essentially graph in the rest of the function. So sketching in the rest of the function here, we end up with following the asymptotes, going through the zeros. Okay, and so it looks like this, and then we don't need any coordinates for here. We just need to know that it fits in there. Although if you want to be more accurate, you can find some coordinates. But what I will expect is just knowing which two quadrants it's in. That we don't need a lot of detail for this section here.